Hello students, welcome to NEET CET Mentors. It is a recorded class. We have told a live class, but due to technical issues, we have made it recorded. Okay, sorry for that. And today's the topics are semiconductors and atoms. Totally, including both chapters, we have collected 21 questions. Each are with the different models and which are important also. There is a high chance of getting a questions. Totally expected questions from the including both chapters are 4 questions. Okay, 4 to 5, almost 4 questions will comes, and go on solving questions with simultaneously with me, and try to solve before me also. I will be giving a half minute extra after solving a question. You can again recollect the things, recollect and visualize the questions. Okay, how the steps are going on. Try to visualize the questions and solve, not blindly. Okay, then without wasting a time, starts the session today. Okay, first question. The circuit shown in the following figure contains two diodes, that is D1 and D2. D1 and D2, each with a forward resistance of a 50 ohm. They have given a forward resistance for this, that is 50 ohms. For both, it is a 50 ohm. Okay, with an infinite backward resistance. The resistance even I will tell you that later. With the infinite resistance for the backward diode is given. Okay, if the battery voltage is a 6 volt, given 6 volt as a battery voltage, current through the 100 ohm resistance is in amperes. You have to know. Okay, current through the 100 ohm, they are asking for this resistance, how much current is going. Okay, just visualize this question. See, understand this circuit. This is a positive potential, this is negative potential of the voltage. Okay, when current flows through this, example, let's take I here. It will be distributed to both. It can go here also and here also. But see here, on going this through this circuit, you know, this is which is opposite to the circuit, opposite to the ongoing current. So when the diode is opposite to the ongoing current, that with the infinite resistance, it is told in the question, then the current will not flow through this circuit. Please remember this. When the diode is in reverse biased, the current will not flow through this that particular circuit. So the current will not flow here. The current only pass through this circuit. So understand, we have to consider this circuit only, not this circuit. You have to cancel this particular circuit. Then I will go here, current 50 ohm resistance, and this is 150 given, and again it will be 100 given. Solving that question, firstly, I is equal to basic formula with Ohm's law, it is V by R, that is voltage by resistance. The voltage that is given is 6. The resistance given through this is, we have to find. I will tell some basics here. Please remember this. Firstly, see, when the series circuit is given with the series resistance, I will tell you the condition of current and also the voltage. Okay, two cases I will be discussing now. When it comes to the current in the series case, what happens, you know, current in series is always equals, that is IA, IB, IC. The total current will be same throughout the circuit. If you take a parallel, then the current will be get added, that is IA plus IB plus IC, like this. This is for current. When it comes to the voltage, through the series, voltage will be get added, that is V1 plus VA plus VB plus VC. When it is in parallel, that is VA equal to VB equal to VC. This is what the important conditions we have to remember to solve this circuit type of questions. Okay, yes, let's get into solve this question. So See here, these two resistance are in series. Then the current flowing through the both resistor is same. That is what I am going to conclude here. The series resistance Ia equal to Ib, that is with both the resistance the same current will be passing. So 6 by total resistance, how much they have given, that is 150 plus 100, which will be 6 by 250. By solving this we will be getting 0.02. This is what answer we got. For that the second will be the correct answer. I will be telling you a second means in this problem only the cases I will be telling. For a voltage, if they are told to find a voltage at a 100 ohm resistance, if they ask, it means how to find this. By Ohm's law, V is equal to IR. The current they are given, that is 0.02. For the resistance 100, so the answer will be 2 ohm. For the 150 resistance they have given, no? Then the current will be current at 100 volt, current at voltage at 150. That is current into resistance of the 150. That is 0.02 into 150, which will be 3 ohm. See here, voltage total given is a 6 volt, but we got a 100 ohm resistance 2 volt and 2 volt, and with 150 ohm we got a 3 volt. Where is the another one voltage we got last? That is, see here we have given, we consider this circuit where 50 ohm diode is given. So there just find the diode volt current into resistance of the diode. How much current value given? 0.02 into what is the resistance there? 50. So we got 1 volt. This is what totally, by adding this we get 6 volt. So for the two cases I have explained here, for current also and voltage also, and how there are with a series and parallel the current values goes. In series current will be same throughout the circuit, in parallel voltage will be same throughout the circuit. Okay, just solve it, try to analyze once again. I will be giving 20 to 30 seconds. Okay, just solve on your own. Okay. Yes, move on to the second question. Find the voltage at a AB region. Yes. In this following circuit, see here, visualize it. See, in this, okay, this is a 10 ohm till this, okay. When it comes to this and this, these two resistance are series or parallel? Tell me. Those two are in a parallel. So just remember that. And they are asking voltage at a AB. See here, this what does this bias includes? Is this forward or backward? Forward or reverse bias? This is forward bias. Okay. Yes, try to solve that. Here you have to remember one basic formula, that is V at any region, that is example V at AB is voltage at AB is equal to the voltage total, that is total voltage divided by the total resistance, that is above given is at 10 and below. If you consider it parallel, that is, you know how to easily find the parallel resistance. Resistance parallel is equal to, if two resistance are there, means R1 R2 by R1 plus R2. This is the basic formula. By this calculation, see, 10 into 10 by 10 plus 10, which will be 100 by 20, which will be 5 ohm. Okay. The basic formula, coming to the question solving, VAB is equal to V total by the resistance through this circuit, that is 10 ohm, adding to that, which is 5 ohm. So the total voltage given is 30 divided by 15, which will be the formula in this voltage at AB is equal to V total by total resistance into what, you know, this resistance, that is we are the resistance at what we are finding, that is in this circuit, no, that is we have to put a 5 here because we got this answer from this step. Okay, the total resistance into which particular circuit we are finding. Example, V total means 30 volt. After that, the total resistance means 10, and these are in parallel. We got 5. This is what total resistance. But we are finding VAB region, right? For that, this to this circuit, how much resistance will be there? That we have to put on the multiple value, and we will be getting the answer as a 5 3 is a 3 10, that is a 10 volt. The answer is a 10 volt for this first option. Take 20 seconds and try to recollect the things. Okay. Yes, next question. The following configuration of a gate is equivalent to. The particular gate is given here, and we have to find out, is it like example NAND or XOR or none of these. The 4 options are given here. How to solve these type of questions? For these type of questions, we have to know some basic formulas, basic theorems. You know, from the De Morgan's theorem. According to the De Morgan's theorem, the output Y is equal to A plus B dot A bar plus B bar. This is what the De Morgan's theory says. Okay, by solving this question, how to tackle means, you know, I will be telling you briefly. OR gate, this is OR gate, this is NAND gate, this is AND gate. What is the OR gate? How to write the OR gate means, OR means A plus B, that is adding the equation. Again, the reverse of that is NOR gate, that is A plus B bar. Again, with the AND gate, what is the AND gate value? That is A dot B. How to express it? A dot B. When it comes to NAND, which is inverse of that, so A dot B bar. Okay, with this basics we can try to solve this question. Okay, see here, I will be writing on this question only. A and B given, they are going in this way and this way. For this circuit like this, B is coming here and B is going here, A is coming here, okay, this, and A is going here. The output of the OR gate I have shown here. Output OR gate means adding, okay, we have to add this A and B, A plus B. When it comes to NAND gate, I have given here NAND gate A dot B bar, that is A dot B bar, and this A plus B expression and A dot B going to the AND gate. What is the AND gate? Whatever it will be, that is A dot B we have to put. That means, for if you consider this as A, this as B, then what will be means, the answer will be, output will be Y is equal to A plus B dot A dot B bar. This is the output there we are getting, and we have to solve that output, and for what gate it is matching, we have to see. Yes, from the De Morgan's theorem, you know, again this is what De Morgan's theorem, and see, Y is equal to A plus B dot a bar a dot b bar. This expression we got from the output y. We have to solve this question, solve this particular through the De Morgan's theorem. De Morgan's theorem tells there, see, this is there is a multiplying equation. We have to solve this question by multiplying this to this, a to a to b, b to a, b to b bar, like that. Okay, like that I have to solve. You know, from the De Morgan's theorem, what tells means a dot b whole bar, if it is there, means it will be a bar plus b bar. This is basic, that is De Morgan's theorem only. We got this from De Morgan's theorem. We have to remember this and we have to apply that. Okay. Firstly, a plus b dot a dot b whole bar given. From the De Morgan's theorem, a dot b whole bar is equal to a bar plus b bar. Okay, so we can write this a dot b bar as a bar plus b bar. Okay, so we got this type of equation. Then we have to multiply this to this, like this. Okay, then a dot a bar plus ab bar plus ba bar plus b bar. Okay, again see here, if the again basics, that is a note point, the same a expressions with one bar on inverse means this is inverse, this is actual, then it will be cancelled. B bar, like this, means this is again inverse, this is inverse, and b will be cancelled. So for this expression 0, for this expression it will be 0. So we will be getting a b bar plus b a bar. This is XOR gate equation. This equation is a XOR gate equation. Don't get panic. I will be explaining how in the next problems how these gates are get calculated with. We can do that by putting the 0 and values. You can do that clarification. Okay. Just visualize this. I will repeat it. Okay. In the following equivalent to, just firstly we have to find the output. What is the output? For that there is given OR, NAND and AND. Example AB going means for the OR gate it will be A plus B, that is adding equation. For the AND gate it will be multiplying equation. After A plus B and A dot B whole bar going, no, we have to multiply that. Then we got A plus B dot A dot B whole bar. From the De Morgan's theorem we got A dot B whole bar is equal to A bar plus B bar. We can write this expression as A bar plus B bar. So when you take this A dot B bar as this, means we have to write just once like this, A plus B dot A bar plus B bar. Then we will be getting A bar plus A B bar and B A bar B B bar. You know, example I will be telling this solving. Okay, how to solve that, how to clarify that. Example, take A as a 1 dot 1 bar is equal to what? Tell me. 1 bar means 0. 1 into 0, 0. If you take the value as a 0 dot 0, 0 dot 0 inverse, then what is the value? 0 inverse means 1. 0 into 1, 0. This is why we are cancelling the both and putting the 0. The value comes 0 for the when we put the values. Okay. After that, these two only remaining. For this expression is a XOR gate. Is it okay? Yes. We will be going to the next question. Okay, we will be solving the next question. In the semiconductor, what happens, majority circuit questions will comes. You just visualize those questions, okay? There is nothing like difficult like that. You have to visualize once, it will be easy for you. There is nothing rocket science, okay? Yes. Starts. The diagram of a logic gate is given here below. The output F of the circuit is represented by. What is the output F? As you know, we have solved OR gate equations. The OR gate, for the OR gate, expression will be A plus B. For the AND gate, expression will be A dot B. W and X is given. So for the OR gate, W plus X will be here. For the OR gate again, W plus Y will be here. When W plus X and W plus Y coming to the AND gate, this is the AND gate, it will be multiplied. That is, F is equal to W plus X dot W plus Y. Okay. See, just once try to match the options. Is it there or not? It is not there. It is not matching with any expressions here. Then it will go on solving what expression lastly we are getting. Just go on solving, okay? Yes, keeping this, I will solving here. F is equal to W plus X dot W plus Y. Cross multiplication method. Just doing this with this and again with this and this. So we will be getting W dot W plus W dot Y plus X W plus X2 into Y. So guys, we have done what we have done there. I will be telling you basics example. W dot W expression will be W only, and again 1 plus Y will be 1 only. How I will be explaining. Example, take a W is equal to 0, then 0 into 0 will be what? 0. If you take a W as a 1 means 1 dot 1 will be 1. What we have taken for the single value, that value will only we are getting. If you take W is equal to 0, output will be 0. W is equal to 1, W 1. Again 1 plus Y is equal to 1. How this basic work means, take a for example, with Y is equal to 0, then 1 plus 0 is equal to 1. Take a Y is equal to 1, then 1 plus 1 is equal to 1. Not a 2. If it is adding means you have to see the greater value. If it is multiplying means it's exactly what multiplication value is. But adding not comes to 2, it's again 1. Please remember this basics. This is basic and very important. You have to use these functions. Remember these two functions. This will help in this solving this question. Okay. W dot W, we can write this as a W only plus WY plus XW plus XY. See, we can take a common here for the W, that is 1 plus Y, again plus XW plus XY. See, 1 plus Y, what I have told, this is 1 only. So W plus XW plus XY. Again, just again solve this question. That is, we can take a W common here and 1 plus X plus XY. Right. Again 1 plus X. It's like 1 plus X is the same form of 1 plus Y. We can write this as 1 again. That is W plus XY. X dot Y. See this. This expression is in the option number 3. This is how you have to solve this question. See, I will be recapping it. Just see the gates and put the values. That is OR gate W plus X, again OR gate W plus Y. Going to the AND gate W plus X dot W plus Y. Taking that equation, you have to cross multiply this. Okay, then we will be getting wy plus xw plus xy. The basics, that is, for the same multiplying functions, if it is there means the same single value only you are getting from this basics. And after solving this, we will be getting 1 plus y functions. These functions will be giving them one answer, one only. So we are putting those value here, and we finally got a, by simplification, w plus xy. Yes, take 20 seconds and visualize that. Okay, try to resolve it. Next, we will be moving on to the 29th question. Okay. The output from a NAND gate is 0. You know how the NAND gate will be 0 when the input A, B, C are such that. Okay. Just see what is the AND gate? Tell me. This is what AND gate. If you put A, B, the output will be A dot B. Like that, NAND gate will be inverse of the AND gate. That is, if you put A and B, then we will be getting A dot B inverse. Okay. For this A dot B inverse, how we will be getting the, we have to match the any, like they are putting 0 and 1, they told to find the values. See the options, they have taken 0 and 1. Okay. I think the NAND gate output they have given 0. Okay. See, this is where the truth table will comes into the topic. What is the truth table? Just make a 3 columns and 4 rows. Okay. In the example A, B and C also they have given C, and output is also given, that is Y. Output they have given 0 for all. For example, take simultaneously you can 2 inputs. Okay, just I will be telling you, if you take 0 and 0, what is the output of the NAND? See here, 0 into 0, 0, inverse is equal to 1. So we can't take the 0 dot 0 equal to 0, which will be 1. We can't take 0 as a 0 in the expression. Okay. Again, if you take 1 and 1, then 1 into 1, 1, inverse is equal to 0. Yes, there is matching with the AB value as a 0. A and B value will be 0. If you take you have to find for C also. If you take 1 and 1, A and C, then A dot C bar, 1 into 1, 1, 0. Again, A dot C bar we will be getting 0. If you take for B and C and check the answer, B and C, that is 1 and 1 here, 1 dot 1, 1, inverse is equal to 0. See, is there anything works here? When we have taken 0 for this equation, the output was 1, which is not matching for the output of the NAND gate. Okay. When we taken A and B as a 1, we got answer 0. When we taken A and C, we got answer 0. Output as a 0. Again we have taken B and C for the 1. Again we got the answer as 0. So we can say A, B, C is equal to 1, and the output of the NAND will be 0 for this question. Take 20 seconds and resolve it. Next question is like this. The current in the branch of a circuit shown in the below is. What is the current in the shown below circuit? See here. They have given -4 volt here, and the diode is given here. From this diode it is forward. Remember this, okay? If this is for this when coming to this through this this is a forward bias. Next 300 ohm and minus 1 volt. Main basic we have to know what what is the basic. See here students, current, that is current always flow from higher voltage, that is higher voltage, to lower voltage. Current always flow from higher voltage to lower voltage. Example, if you have a plus 5 voltage here and plus 1 voltage here, means the current will flow from here to here. If you have a 0 voltage here, means, and minus 1 voltage here, means the current will flow from here to here. If you have a minus 1 volt here and 0 volt here, means the current will flow from 0 volt to minus 1 volt. That is higher value. 0 is a higher value, minus 1 is a lower value. Like this, from where the current is flowing, just see here. For example, see minus 1 volt and minus 4 volt is given, which is a higher value. In the negatives, the lower value, lower quantity will be the higher value, okay? Lower quantity will be the higher value. Minus 1 volt is the bigger value here. So current will flow from minus 1 to minus 4. If we consider that current will be going here with the example, expression I will be giving, minus 1 volt, again 300 I. See, when we are going like this, we are facing a reverse bias here. What is the reverse bias meaning? Reverse bias means it will be having infinite resistance. Infinite resistance means whatever the current it is passing now, it will be considered as a, it will not allow the current to flow through this, not allowed. So the current will be not going through this circuit. They are told to find the current value, but according to the law, that is higher voltage to lower voltage, we are finding where infinite reverse diode is there, so the current will be not flowing through that circuit. Is it okay? If at all there is a plus 4, I have solved the example here. See, higher voltage, this is lower voltage, the current will flow like this. See 0, which is the neutral, and minus 1 means lower value, so current will be flowing like this. See, minus 1 value and 0 value, where from where to where? From 0 to minus 1, like this, okay? This is how these type of questions will be solving. If at all there is a plus 4 here and a minus 1 there, means we have to solve this question. I will be taking that case only. See, plus 4, I will be teaching you the second case here. Plus 4 and like this forward diode and 300 ohm, and we have a minus 1 volt. See, plus 4 volt. See, now you know this is higher value, this is lower value, the current will be flowing like this, and this is a diode is in a forward bias, so the equation we can write. See how we can express the equation. See, 4, according to Ohm's law, they have not mentioned any resistance for the diode, so we are not bothered about that. Next we are getting 300 resistance into current going. Next we are getting minus of they have given minus 1 volt, so minus 1 volt is equal to 0. Minus into minus plus 1 plus 4 minus 300I is equal to 0. So 4 plus 1 5 minus 300 plus 5 is equal to 0. I is equal to minus 5 by minus 300. So we will be getting minus minus get cancel. 5 by 300 means 5 6 is 0, that is 1 by 60. I is equal to 1 by 60 is the watt, ampere. We are getting if it is plus 4 sign for this and the same is given here. This is how both cases I have solved. If it is a reverse bias, don't just we put a 0. If it is forward bias, according to Ohm's law, you have to solve this question. Okay, just solve it, resolve it. Yes. See, in this question, yes, current in the circuit will be, see the circuit, current in the circuit will be, they are asking the total current through the circuit is. You know, again, this is the positive potential, this is negative potential, the current will be, if you can always take a positive potential as your starting point, which will be easier to solve, okay. If the current is flowing like this means, with the 20 ohm, it will be going, after that I will be going here, there is a junction here, there, divided into parallel. See, when I flow through this, you know, this is forward bias, where forward bias allows the current to pass through. Here, after going through the 20 ohm, it is going here, where, you know, this is a reverse bias. Reverse bias means there is no flow of a current. There is no talking of the current pass through the circuit. So we have to consider only this circuit for our discussion. Okay, just cancel the above circuit. You have to follow this circuit only. From that, see, we can write the expression now. There is a 5 volt and minus 20 into I, forward bias taking the this circuit, minus 30I is equal to 0. So I value will be minus 50I, 5 volt is equal to 0, 5 volt is equal to 50I, take a 50 below, that is 5 by 50 is equal to I, that is which option? 5 by 50 is the answer. Okay, that is I is equal to 5 by 50, where we will be getting, they are not, we can put that as a 1 by 10, but in the option they are stopping at 5 by 50 only, so we can put this answer. I think you got clear about the forward and reverse bias, how it works in this. When you cancel the reverse bias, no, you will be getting a simple circuits you can solve very easily. Just see the circuit and visualize once what is happening in this. Okay, after that put a pen on paper and going to solve. Okay, just take 20 seconds and resolve it. Yes, it is. Yes, students. In the following circuit, the output Y for all possible inputs A and B is expressed by the truth table. Just put the values, that is once for the A, put A and B. First put a truth table. Okay. A, B and output will be Y. And 0 0 0 1 1 0 and 1 1. See, I have made this question here only by writing. See here, if you take this is again we have type NOR gate. This is NOR gate. Okay. For the NOR gate, expression will be a plus b whole bar. Again here a plus b whole bar. If you put 0 0 here, I will be explaining you. If you put 0 0, 0 plus 0 0, again inverse will be 1. The same one equation if you take 1 plus 1 1 bar will be 0. For the second case, so output will be here 0. If you take 0 as a and 1 as a b, then 0 plus 1 will be 1. The inverse will be 0. Again 0, we got a 0 there. Again 0 plus 0 will be 0, inverse will be 1. In the third case, for the output will be 1 for the second case, and third case 1 and 0. 1 plus 0 1, inverse will be 0. 0 if you put 0 plus 0 0 will be 1. That is output 1. In the fourth case, if you put 1 and 1 for a, 1 plus 1 1, inverse will be 0. Again 0 plus 0 0, inverse will be 1. So output will be 1. See, from this we are getting the output y. When the AB are 0, the output is 0. For all other cases we are getting value as a 1. This is how we have to solve. Match this expression, match those answers we got. This is matching with the option A. This is how truth table works. Okay. This is all about the semiconductors. We are told atoms will be solving, but for the technical issues and that we are solving the atoms in the next session. We are only solving the semiconductor, and we have solved all type of questions. These 9 methods, you are getting at least 2 to 3 questions from these topics. Okay, just revise these particular cases. And physics, at least we have to give 3 hours per day, 2 to 3 hours per day as usual. Day by day solve those questions. At least you have to solve 20 to 30 questions per day last days. Okay, this is how the whole session goes. Thank you. I will be coming tomorrow again.